In this video, we'll demonstrate the operation of phase dropping, digital tracking, analog tracking, and a special feature which allows the user to program the fault response of the part, save it in a file, be able to come back and bring it back and start off at the same point that they left off in their evaluation. Now let's look at the connection of the hardware. The usage guide shows a detailed connection of our dongle board, which converts USB to I2C to be able to talk to our controller, and also shows you the connections that need to be made. There's two wires going from this dongle board to our eval board and connected as follows. The one thing to note is that pin 1, which has a little mark on this pin here, goes in this position here. Also on the top of this board, 48 volts is connected here. For this particular setup, all of these 48 volts and grounds are connected together. So you can, if you want to share the power, you can connect up each individual one to share the load. In this particular case, for functionality, we just connected up 148 volts. We did the same thing with the load. Each individual phase has the ability to connect a load to each one. Again, all phases are connected together. And so now we have to be able to connect two supplies to this board. The first one is a 5-volt supply, which is our pre-bias. So we'll connect our 5-volt supply to here, coming up to our supply. Then for our flyback and our VN, we have 12 volts and ground, and we connect that through this supply. And we have to have a common ground between both supplies, so we'll connect both supplies together. Figure 13 in the user's guide shows the connection for the scope probes. And now let's go to the operation of the GUI. In order to perform phase dropping, the user needs to remove jumper 35 on the eval board. We can check the status of that by going to Config Status tab on the GUI. And from there we can see that the phase drop is in fact disabled. And in order to enable it, we need to remove jumper 35 on the eval board. After powering the board down, which is recommended because it's a high-powered board, that before we make any changes to the board, we want to totally power the part down and then make the changes. So we've done that. We've pulled jumper 35 out and now powered everything back up. And you can see from the GUI, after hitting the update status pin, that now the phase drop is enabled. And indeed, we've gone from 6 phases to now 2 phases. So now we're going to go ahead and increase the power, the load, to 50 amps. And now you can see after updating the screen that indeed we have gone to 3 phases. Now we'll increase the current to 85 amps. That should take us to 4 phase. I'll update the status. And you see we're at 4 phases. And then finally we'll go to 120 amps. And from the configure status screen on the GUI, we should be able to see that indeed we're now operating at 6 phases. Okay, now there is a hysteresis in the operation of this. So if we drop to 105 amps, we're still at 6 phases. So if I go to 100 amps, I should now drop to 5 phases. Actually, I'm sitting at 4 phases. If I go to 65 amps, I should drop to 3 phases. And I do. And then finally to 30 amps, I should be back to 2 phases. And I am. So you can see that there's a hysteresis going on the way up. In order to go from 2 phases to 3 phases, it takes 50 amps. On the way down, it's 30 amps, and so on. For digital tracking, this is the default screen when we start the part up. We need to come over here to Control Registers tab. We'll bring up the Control Registers tab, and down here on the B-4 tracking, we have the options of either making it digital tracking or analog tracking. So for this particular demo, we're going to show digital tracking. So once I select that, I need to come up here to right to the registers, and then I can come over here and click and read and verify that it did indeed take my input for digital tracking. Now that we've selected the digital tracking mode, let's go and show you what it looks like. Now we're putting in a signal, which is a PWM signal, into the input of the tracking pin on our device. And by adjusting the pulse width, you can see the orange line is my output voltage. And so my output voltage, as my pulse width increases, my output voltage increases. As my pulse width decreases, so does my output voltage. So now I have a digital way of adjusting the voltage of my supply as a function of this tracking pin. So now, to demonstrate the analog tracking, we have removed the PWM pulse from the track pin and replaced it with a supply. The input voltage of that is going to be anywhere from 0.6 volts to 1.2 volts. And we've gone onto our control register screen and changed it to analog, wrote to the combo, read it back to verify that we are indeed an analog. And so now the red trace is the input voltage and the orange is the output voltage. And you can see now as I change my input voltage, my output voltage will track. And there's the demonstration of the analog tracking on the ISL78226. Now I'd like to show a feature of the GUI that enables the user to customize the response of the ISL78226 based on faults that may occur in the real world during operation, and save these settings so that the next time they pick up the evaluation, they can start where they left off. From the startup screen, we'll click on ISL78226. And that brings us to the startup screen. If the board has previously been powered up and verified to be functional, then the user can use the automatic startup sequence. They'll do that by clicking on Read the Startup File options. When they do that, what will happen is it'll set the enable pin on, which is equivalent to pressing our enable pin here. It'll read the ID and revision of the software, clear any faults that's in the software GUI, and set the PWM, which was equivalent to pressing this button on, which powered up our part. So to automatically start the part, we'll click Execute Startup. This box will tell us that it's running, and when it's complete, it'll say Startup Completed. From here, we'll click over onto the Control Registers tab. The initial startup will automatically bring the ISL78226 in a protected configuration with overvoltage and undervoltage limits set to auto self-start or hiccup if a fault condition is detected, as shown in the grayed out boxes on this screen. Before we talk about this screen, I'd like to discuss the function of the mode pin. Here's a schematic of the circuit that is on the evaluation board. The mode pin tells the ISL78226 what mode to operate in, either diode emulation or constant current mode, or what fault response to have. So this circuitry is on the eval board, and the level of output voltage tells the part which modes to be in. This truth table tells us if I ground the input in 0 volts, I'll have hiccup and diode mode in emulation mode. If I set about 1 volt on this pin, I'll have hiccup and continuous current mode. If I have about 2 volts on this pin, I'll have latch with diode emulation mode. And if I tie the pin to VCC, then I'll have latch and continuous conduction mode. The GUI enables the user to change the function either from diode emulation mode or constant current mode by clicking on this pin, or the response to a fault, either hiccup or latch. We're going to go ahead and leave it in the default conditions of diode emulation and hiccup. Now if I want to go ahead and customize this part, I'll go ahead and click on this to enable this screen. I'll write to it, and you can see that all my combo boxes now have been automatically set to flag, such that I can go in now and determine what it is that I want to do if a fault occurs. So let's look at what my options are. I have a flag, which is if it's set to flag, if this, in this particular case, the overvoltage on the 12-volt supply is reached, it will set off a fault and do nothing. It'll just tell me that, hey, I've gone over voltage. I can also set it for auto start, which means that if this fault occurs, it will shut the part down and then automatically monitor that pin, and when it comes back into regulation or the limit, it will then automatically restart the part. Another option I have is latch. In this option, if it's selected, if I hit that limit for the overvoltage, then it will just shut the part totally down, and the only way I can repower it is to restart the supplies by myself. And this one here is redundant with flag. Another option not shown on that combo box is hiccup. Hiccup is a function in which it'll shut the part down if the fault occurs, and every 500 milliseconds it will power the part back up, see if the fault is still there. If it is, it'll shut down. If the fault has now gone away, it will then power the part back up automatically. So let's go ahead and for this demo, we're going to go ahead and just set this entire row to auto start stop and hiccup. That'll make it easy for us to see that indeed my changes have occurred. So once I set these, I now need to write them to the combo registers. I will then read to verify that they're there, and they are. So now at this point, I'm going to go ahead and turn the part off. And then go away and come back another day. So now when I come back to restart this process, I can pick up at the same point I left off by clicking two different boxes on my startup menu. So again, what I'll do is I'll click my read startup file, and it'll do everything else, except now what I have to do is I have to update the device control registers from the file, and I have to read the control registers and status. So by clicking these two boxes now, I'll be able to read that file that I set, and I should now have my limits and be able to pick up where I left off. So now I'll hit execute, and you'll see once it's going off and reading that file, it does take a little bit longer for the startup to run. So now it's completed. I'll come over to my control registers, and we'll go ahead and enable it. And indeed, instead of having all flags like we did initially, you can see that my changes have been ported into the thing, and I can continue my analysis of the part where I left off.
This concludes a brief introduction of the ISL78226 GUI. For more information, please reference our user's guide or contact our technical support at intersil.com/support. Thank you for your time.